Hello, folks. Hey, I had a request on the online to create a video showing how to create a hex bolt based on a tutorial that TooTallToby had illustrated and done in Onshape, and the user wanted to see how to create that same bolt design in Alibre using the tools that we have in our program in Alibre. Obviously, we don't have all the shortcuts and everything that Toby was using on his video, so I'm not going to be using any shortcuts in this demonstration, but I'll use the menus and the in-place sketch menu that pops up once in a while. And then as far as moving the view, I've got a 3D connection SpaceMouse that I'm using to manipulate my view. So when you see parts moving around and there's no obvious movement of my mouse, that's the 3D mouse manipulating the view. So with that, let me get started here. We'll start off with a sketch on our ZX plane. So right click on the plane and select Activate 2D Sketch. And then up in the ribbon, we're going to grab our regular polygon tool. And in Alibre, this thing defaults to 6 sides and inscribed circle. So there's no settings that you need to make there unless you want to change different size sides or whatever. So in here, we'll click on the origin and drag out to get our sketch for the polygon, and then click apply and then close. Then left click on a horizontal line and the in-place menu pops up, and we'll grab our constraints and add a horizontal constraint. Again, we'll bring up the menu with a middle mouse click and then click on dimension. And now we can dimension either 2 horizontal lines or grab the circle and place a dimension. And Toby had 40 on his part, so we'll use that. And then we'll click on Orient to Sketch Plane to bring everything normal. And then we can just tip it back and go to Features, Extrude, and we're going to go to a depth of 13 to complete the hex head part. One thing he did was rename his parts as he was creating them. And you can either right click on them in the Design Explorer and click Rename, or while you're creating them, when the dialog box is up, there's a field down here called Label. So we'll click on in the label and type in the name and hit enter, and it rename is updated in the Design Explorer. So now the next step was to create the trim cut that he had to knock off the corners of this hex on the top of the bolt. So we're going to right click on the XY plane, activate a sketch, and we're going to draw a vertical line. Grab our line tool, grab a vertical line and a horizontal line. And as you draw them, you can either, if you watch carefully, you'll get the constraints automatically applied to that. And then we'll go up here, we'll grab our arc and select tangent arc, select the right end of the horizontal line, left click on it to select it, and it attaches the tangent arc to it, and then select the vertical line to complete the arc. And now we're going to have to constrain this to this corner. So we need some reference geometry here. And we're going to do a project to sketch. And in this option here, this command, we're going to grab the sketch off the Design Explorer. And this is a sketch that we use to create the hex. And we're going to create reference figures and maintain the association toggle, make sure that's on, and click OK. And now every entity of that sketch is projected onto the XY plane. The nodes here that you see are the endpoints of those reference lines, and the ones we're concerned about are is this node here and this one here. That's the nodes. When you look at the sketch, that's going to be the one that defines the circle, the reference circle for that sketch. So now we need to just constrain our our profile sketch to this node, and then this end node to the end node there, and I'll grab our dimension, and I'll just zoom in here to grab this vertical line and click on here to put key in the 2.5 dimension that Toby used on his model, and then a middle mouse click to bring up our in-place editing menu. Go to our features, and we'll do a revolve cut, and for the axis we'll grab our y-axis, and that's going to preview to trim off those corners, the same as what Toby had in his model. So now let me rename this. This is going to be the X head trim. Now the next step is to create the body of our bolt. So we're going to create another sketch. We'll right click on this face, select activate sketch, and we'll come up and we'll grab our circles, select the origin, and we'll drag this out, and we got 20 millimeters, and then we'll go up here to grab our extrude, and we're going to extrude this to 60. And while we have this open, we'll just put this in bolt body and click OK to finish that. Okay, now the next step was that he was going to kind of preemptively place a sketch in here that we can use to trim this corner or end of the body bolt off as a miter. And once you have the threads on here, you can't come in here and do the chamfer. So if he's going to do a 5 millimeter chamfer, you can't do that with the threads up here. There's no way to trim the threads off with the chamfer tool. So we're going to do likewise. We'll start an XY sketch on XY plane. Grab our line tool again, and we'll sketch out the same basic shape that that Toby had here. We'll have this as a horizontal line, and then we'll add some constraints. We're going to do a coincident between this node and this edge, and then some dimensions. We had this one here was at I believe it was 10. We had 12 on this line, 45 degrees on this angle, and then from this line to the axis, he had 5 millimeters in there. And that completes that sketch. So let me just rename this really quick. And that's going to be the miter trim, TRIM, miter trim sketch. Okay. Now if you want to have your sketches turned on so that you see them all the time, we'll go up to the view menu and select this display. We'll toggle our sketches on, so now we can see our sketches at all times. Or you can leave them off just to keep your workspace clear of a lot of clutter. Okay, now the next step here is to create the actual profile for the thread feature that we're going to add in here. And again, we'll start that profile down in the body of the hex head. So we'll right click on the XY plane, start a sketch, and grab our line tool again, go to horizontal, go vertical, put an angle line in here, and then down on the back side, and we'll make this line left click, constrain that to vertical, and then right click on it and select convert to reference figure for that. And then we're going to capture these 3 lines. You can either left click, and you can't do a chain select. Here we go, yeah. You left click on it on one of these lines, and in this menu you have a chain select, and that's going to select all those lines for you. Come up here and say mirror, and our mirror axis will be this horizontal reference line, and then it completes our thread profile except for some dimensions. Now we'll just add some dimensions on here, and Toby used what, 1.5 I believe on the front, 4.2 on the back side, and then let me just reposition this a little bit. We'll drag it over because now we need to dimension it, position it below the surface. Grab our dimension tool, so select this top node and then come up and we'll dimension to this edge, select that, left click, and that gives us a dimension to a reference line, and that's going to be 0.5, and then between this vertical line and the end node there, another 0.5, and then one more dimension here for the total height to be 3 millimeters. And as he indicated on his Toby indicated he could go from this line to the origin or vertical axis too, but we'll just follow his lead on this part here. So now in Onshape, he created a helix that he actually created a plane on, and then set this on a plane that was not vertical to the work plane. Well, Alibre has a helical tool, so we're going to create a helical boss, and what that's going to do is going to grab this sketch and our reference line for an axis, but it's going to grab whatever's reference line is closest to the sketch, in this case the horizontal line here. What we want is actually going to be the y-axis, so if we highlight that box and then select our y-axis, and it's going to adopt our default height of 250, and we want to match our body height and then extend on just a little bit further. So if you click on FX, it's going to open up our the equation editor. So click on the owner column to sort everything according to in order, and then in our bolt body we have 60, so click in the 60 line and then click OK, and it copies the length of our bolt body into our height and readjusts our preview. But we want to extend that beyond, so if we click in here and hit the add 5, hit tab, and that updates our thread now to be beyond the body bolt or body length, and whatever this length changes to, it will maintain that association because those two are linked now. And here we'll change this to thread helix, and then click OK. Whoops, before we do that, we're going to change our pitch. We want pitch to be 5, and we get a nice preview of our pitch at 5 millimeters and stopping at 5 millimeters above the line. Now he made a comment about, because his sketch was made on a plane that was normal to his helix. In Alibre, if you go to the Advanced tab, you have an orientation options here, parallel or normal. So if we click on normal, what that does is it changes the orientation of the sketch to be normal to a plane that would be the same as having a plane on the end of a helix. So notice how the end of our thread profile changed angle here. If we go back to parallel, it's straight up and down. So you want to change that to normal, and that gives you the same effect that that Toby had with his plane attached to the end of the helix in Onshape. And then we'll click OK, and it completes the helix. And then the final step again is going to be our miter trim. So if we come up here and we'll grab our revolve cut, and this sketch we want to revolve is going to be our miter trim sketch, and our axis is going to be our y-axis, and it'll update our preview to trim the bolt body and the thread in one step. And then we'll just call this our trim cut on the end, and click OK, and that completes our hex bolt. So now in our next video, we'll go through taking this hex bolt and creating a hex nut and matching the threads on here with some clearance, similar to what Toby did on his video. So we'll see you in our next video creating the hex bolt and creating matched threads. So thanks for watching.